What other information you can find on periodic table? Well, on most periodic tables poster-like, you can find our notorious electron configuration formula, which is usually at the very bottom. Well, to understand electron configuration formula, let us take another look at the Bohr model. It shows electrons moving around the nucleus in several separate energy layers called electron shells. And on our model, the circles represent these electron shells. Well, the circles are not how electrons are moving around the nucleus in space. It's not like planets moving around the sun. Well, the location of the electron at any given time is somewhat a mystery. Well, there is a probability formula, which I would not recommend even looking at it, as it might be as bad as looking at the Gargon Medusa from that Greek mythology. Well, listen to what you can read about those mysterious electrons. When electrons jump between shells, they did not travel between them. They just disappeared from one and instantly appeared in the other. Or listen to this. Anyone who is not shocked by quantum theory has not understood it. So basically it means if you understood it, you're supposed to be shocked. If you don't want to be shocked, you don't understand it. I don't know if there is a golden middle, but let us take this Bohr quotation as a surviving guide, so not trying too hard to dig too deep into this thing. Because the only reason we're actually talking about it is because school kid is expected to know the electron configuration formula, and it has to do with electron orbitals, which define as a region of space where an electron could be. And if this region has spherical shape, scientists called it s-orbital. And if it has a dumbbell shell, they call it p-orbital. Well, remembering the Niels Bohr quotation, we are not trying to dig deep into how they come up with those shapes, why they called it like that. We're gonna leave it up to the deep divers. That's, by the way, my analogy is to the real scientists who dive in real deep into this kind of stuff, where little us, I picture just taking a stroll on the boardwalk and elegantly waving to those deep divers with a gratitude. We are really grateful for all the data and for the real unimaginably hard work they do to come up with it. But little us, we just want to survive school level chemistry. So let us take this s-orbital and p-orbital as a new cool concept. Say voila and keep going. Well, the last thing we need to know to finally come up with electron configuration formula for our hydrogen is to know that electron for hydrogen is s-orbital. So without further ado, let us see the electron configuration formula for hydrogen. And it's 1s1. And let us see how they come up with it. The first one corresponds to the first electron shell our electron is on, which in turn corresponds to the period our element is on periodic table. Hydrogen is in the first period, so we got the first electron shell. S corresponds to s orbital, and that other smaller one next to s corresponds to the number of electrons on our electron shell, which in turn corresponds to the group our hydrogen is in. And it's group number 1, so we got 1 electron on our outer shell. Well, specifically for hydrogen, since we got just 1 shell, that outer shell or inner shell is the same first shell. So let's just enjoy the simplicity of electron configuration formula for hydrogen for now. But we will get down to that concept of outer shell and its importance once we continue making models for elements on our second period. But for now, let's say, voila, we got our first electron configuration formula for hydrogen. And hopefully you grasped the concept of it, at least a little bit. And as we continue making models for other elements on periodic table, hopefully you'll get it down cold, and who knows, you might become an expert on electron configuration formulas. Well, but let us see. It looks like we covered everything you can usually find on periodic table for hydrogen. So it means we are done for our hydrogen atom model. And we'll continue making model for our next element on the periodic table, which is helium.